Just one, and then what am I left with? Is she right? I'm just listening to Emmy, but Sam's saying a little slur. Is that right? Are we trusting Emmy? Ellie? Why am I trying to call Emmy out? She's not even new. No offense to Emmy. It was Ellie. You did what? We could do that. And that would change all our signs. But I'm not going to go back. I already wrote it in pen. I'm going to let it go. Someone help me with the next one. What's the next term? M to the what? And then what?
3n
To the? Okay, and then last but not least, plus 4. Okay, terrific. Okay, someone help me with this, and then I will gladly help you with 7-6. What am I supposed to do? What is the formula for this? I knew you would help me. So you're supposed to do base 1 plus base 2, and you divide it by 2, and then what is this middle line called? The mid segment. Again, yesterday in our justification question, there were quite a few people who put midpoint rather than mid-segment. This is an entire line, so if you call it a point, we kind of have an issue with our vocab terms in geometry, and you look silly, and you don't want to look silly because you know what you're doing. Okay, so I should do 6x plus 4 plus 10x minus 2 divided by 2, and that equals 5x plus 10. This has gotten super complicated. Anyone want to tell me a good next step?
Multiply by 2.
I could multiply by 2 on both sides. If I multiplied both sides by 2, then that fraction would go away, and I would have 6x plus 4 plus 10x minus 2 equals what? 10x plus 20. She's made sure she distributed. There are still some who are stinking at distributing. No wonder you keep doing poorly. I'm sorry. I'm just being straight up blunt today. I need to let it go.
Please pardon the interruption. May I have your attention, please? All football players, THS football players, at this time, would you please come to the field house for a special meeting? All football players, at this time, please come to the field house for a special meeting. Thank you.
It's not even football season. Okay, bye, Gage. Okay, 6 plus 10 is 16. 4 minus 2 is 2. I ended up with this. Someone help me finish solving. Okay, if I subtract both sides by 10x, I have 6x plus 2 equals 20. Now what do I do besides unslam my door? Subtract 2 from both sides, so I have 6x equals what? And then what is x equals? X equals 3. Perfect. Then I'm very happy with that, and I will gladly answer Derek's question on the study guide in like 2 minutes after I do a brief summary of what we talked about yesterday. Because apparently somehow I went wrong. So yesterday we did 3 examples about dilation. A dilation is like when the doctor puts the drops in your eye, where we can either get enlarged or reduced. So you're told A is the first shape, B is the second shape. So the first thing you need to say is, was A enlarged or was A reduced? And he was reduced, so it is a reduction. If it is a reduction, then we expect our scale factor to be a fraction, so it's going to be less than 1. If it is an enlargement, so we got bigger, then we're expecting a really big scale factor. That just makes common sense. Smaller would be a fraction. Enlargement is going to be a really big number for a scale factor. Okay, we can count the sides to figure out the scale factor. So we can count along the bottom. 1, 2, 3, 4, 5, 6. I went over 6 blocks from here to here. I always put the original in the denominator. And in our case, the original is A. And I believe that's the case on the study guide and probably on the test. So, at least in our class, for now, A goes in the denominator. So I counted across 6 on the bottom. I need to count across here on the bottom. It would be 1, 2, 3. So 3 over 6. That reduces to 1/2. I'm going to do the same thing on the side. So I go up 1, 2, 3, 4. That 4 goes in the bottom because it was with A, and A is going in the bottom. I go up 1, 2 on B, so 2 over 4. That reduces to 1/2. Besides my 3 girls who weren't here yesterday, is there anyone who is confused to here? Okay, well then the only confusing part is when you can't count it easy, like this slanted line. So you can either use the distance formula, you can count using the distance formula, and we talked about how to do that yesterday, and apparently that's where I lost you. Or, all Ellie really has to show me on her paper for me to understand she knows what she's doing in math class is the following. No, we're sorry. Thank you. Okay, so what did I just tell you? Is it your world?
No, I wasn't asking.
Is it your world?
No.
It's my world. What are we doing right now in my world? Help me with my world and I'll help you with yours. Otherwise, I'm not going to help you with yours and I'm just going to get angry. Okay. So, what I could do is count from here, up, and then over. So I went up 1, 2, 3, 4. I went over 1, 2, 3, 4, 5, 6 on the pink line. And I could count how much I went up and over. On B, I went up 3. Nope, I went up 2. Miss Compton count. 1, 2. I went over 1, 2, 3. 1, 2, 3. So 2 over 3. That's all Ellie actually has to show me on her paper. If I see she counted 4 and 6, 2 and 3, she's smart enough to realize 4 divided by 2 is 2, 6 divided by 3 is 2. So really, that last third side is still in proportion. So she does have the same scale factor on that side. She does not have to do more than that. As long as I see Ellie attempted that third weird slanted side, I'm going to give her her points. The good news for Ellie is that I know for sure one of them on the test, because there are 2. One of them is just a straight up rectangle, which we can't mess up counting. Are you happy now? Are you happy now? Okay, is everyone happy now except for the 3 girls that would like for me to do another? Okay. If you're happy now, you can, like Derek, move on to other things. I'm going to continue to talk to these 3 girls. Okay, so we're going to do the exact same thing on this one. From A to B, did it get larger or smaller? It got larger, so we're going to call that an enlargement. So we're thinking our scale factor is going to be a number bigger than 1 because we got bigger. Okay, so I need to know how long A is on the base. So I count the squares. I went over 1, 2. Do you understand how I got the 2? Okay, so I always put A in the denominator, so I'm going to put A down there. If I wanted to, I could go ahead and count A on the top as well. That's going to be a 2. So in another fraction, I'm going to have a 2. Heck, I could even count A on the sides. That's a 1. That's a 1. So in my last 2 fractions, A is going to be a 1 in the denominator. Are you good with this? Okay. I'm going to have to count B the same way. So how long is B on the bottom? I need you to count it. 6. So 6 over 2, which is 3, for sure along the bottom. Now count along the top. Let's make sure it's the same. It should be. It is 6 over 2. That's also 3. When you counted along the sides, what did you get? 3. 3 over 1 is 3. What about the other side? 3 over 1 is still 3. So I've showed the scale factor is for sure 3. I checked it with all the sides. And that's all you have to do for that. The very last one is only slightly harder. We're still going to do this counting thing, but we got to pay more attention. Is the giant one supposed to be the original, or is the smaller one the original? Okay, where does it say original? It says it somewhere on the paper. Oh, there it is. Original. So original is MNO. Which one's MNO? Is that the giant one or the smaller one? The giant one. Okay, so we went from giant to smaller. So is that an enlargement or a reduction? Okay, so we're expecting to get a scale factor that's a fraction then. Okay, well I'm still going to need to count. So I need to count from here, from M to N. I need to know how many squares. That's going to go in the denominator. How many? I got 4 for DF. How many did you get for MN? 12. So 4 over 12, that reduces to 1/3. Great, we did the bottoms. Now let's do the side. I know it's 3. 1, 2, 3. I know that one's 3. What was MO? 9. 3 over 9. What does that reduce to? It does reduce to 1/3. Perfect. Okay, and now we would like to check for the third side. Or, you got 2 options. You can either impress me and say, I bet they have a common angle there. I bet they both have a right angle there. And if so, you could try to argue it's SAS. So then you don't have to calculate that third side. Or, if you want to calculate the third side, you would be arguing SSS. And the way to calculate it is still going to be this counting. So I could count how many up and how many over. Did you get 9 up? How many did you get over? $12. Okay, and then we want to do the same thing from here. We're going to count up and then over. 1, 2, 3, and then did you get 4? Okay. Isn't 4 times 3 12? Isn't 3 times 3 9? So that, just showing me that shows me you understood the third side was still having the same scale factor. Because look, 4 over 12 is 1/3. And 3 over 9 is also 1/3. So then you'd be arguing SSS, and that's what I would do. That way it's the same thing every time. It's easy to count when it's the straight across pieces or straight up and down. It's harder when it's a slanted one. Then you have to do this kind of thing. But just showing me this shows me you know what you're doing. Okay, any questions? Okay, then you have to practice ones on the back and the other track. If you're